the derivative of a function at a point. So given a function defined by y is equal to f of x, so let's say, for example, our function is the one described by the blue curve. The derivative of the function at x sub 0, y sub 0 is the slope of the line that is tangent to the function at x sub 0, y sub 0. So the red line is our tangent line. It is tangent to our curve at point A, and point A has coordinates x sub 0, y sub 0. The slope of that tangent line is what we call the derivative of our function when x is equal to x sub 0, or you can call it as the derivative of our function at point A. And so we derive the meaning of the derivative using limit this way. It is the limit of the change in y over change in x as delta x approaches 0. And so this delta y over delta x here, that is the slope of your secant lines. Okay, so we constructed a sequence of secant lines, and those secant lines are approaching the tangent line. The limit of the slope of those secant lines, if that limit exists as the secant line approaches the tangent line, that would be the derivative of our function, if the limit exists. But then again, in our video, we will focus only on functions where the function is differentiable at the point. So this is how we defined our derivative. You read it as f prime of x. So it is equal to this. This is just your delta y over delta x, but we replace delta y by this, because we are going to evaluate f of x plus delta x minus f of x as delta x approaches 0. Getting the derivative of a function at a point is a huge task. We have to divide the task into small pieces. That is the strategy of divide and conquer. That is how I advise you to face the challenge of getting the derivative. Don't go straight into evaluating the limit. Get the derivative using the 3-step rule. Well, what you do is you simplify this. This is your delta y. And then you divide the results of this by delta x. And again, simplify, okay? The third step is this. Get the limit of the results in step 2 as delta x approaches 0. Find the derivative of a function at the indicated point. Get the derivative of f of x is equal to 1 over x when x is equal to 1. So just exactly what are we talking about when we are talking about the derivative? So this is the graph of your function f of x is equal to 1 over x. You're familiar with this. This is your rational function. And there is a tangent line to this function when x is equal to 1. So when you say get the derivative of the function when x is equal to 1, we are looking for this. This is the slope of the tangent line. And what information does it tell you? Derivative is rate of change. And not only the rate of change, there is another layer of information into it. It's the instantaneous rate of change. So the derivative is telling you how quickly is y changing. Change in y over change in x, okay? How quickly is y changing with respect to the changes in x? Let us evaluate f of x plus delta x minus f of x. So that is just this. So many students who are new into getting the derivative using 3-step rule or using the limit, they're quite kind of confused and lost. Where did that come from? Well, it came from this. Our function is 1 over x. 1 over x, okay? F of x is 1 over x. So f of x plus delta x, that's 1 over x plus delta x, and then minus f of x. What do? We simplify this, okay? You get the product of this, that's the LCD. This divided by x plus delta x is x times 1 is x, minus this divided by that is x plus delta x times 1. Okay, so be careful here. You must put that in a grouping symbol, okay? And then you simplify this. When you remove the grouping symbol, this becomes x minus x, that's just 0. And then this one becomes minus. It becomes negative. So negative delta x over x plus delta x times x. What do we do next? We go to the second step and we just divide the results of step 1 by delta x. Okay, so look at this. We divide it by delta x. And delta x divided by delta x is equal to 1. And so we are left here with this, negative 1 over the quantity x plus delta x times x. So what is the limit of that? What is the limit of that as delta x approaches 0? That is the derivative of our function, the general derivative of our function, okay? So as delta x approaches 0, look at this. As this one approaches 0, this becomes x plus 0, which is just x. And then x times x is x squared. So the derivative of our function, okay, is another function. It's given by this. It's negative 1 or negative 1 over x squared. That is the general derivative of our function. And so we must now pay attention to the question, to the original instruction. What is the derivative of this function when x is equal to 1? So you just evaluate the derivative when x is equal to 1. F prime of 1 is equal to negative 1 over 1 squared. And that is just negative 1. And so what information does it tell us? Okay? The derivative of our function when x is equal to 1 is equal to negative 1. That is telling you how quick is y changing when x is changing. And right away, since the derivative is negative and that is the slope of a line, that means your tangent line is descending. It's descending. So that means your y, the value of your y is decreasing. And how fast is it decreasing with respect to changes in x? It's equal to negative 1.